now that you've sort of seen the current state of where things are at in the current gym, it's time to talk about what's happening in the future and some of the exciting work that's happening on the physics simulation side. So I'll just remind everyone about Omniverse. So Omniverse is really where a lot of NVIDIA's efforts are now going in terms of our simulation environments. It's all based on Pixar's USD Universal Scene Description, and we connect everything together, and a lot of wonderful things are happening there. So you can actually get the beta of Omniverse right now. You can download it and start experimenting with some of these features, including quite soon, hopefully, some of these new physics features I'm about to show. So as this happens, what we're going to be doing is we're going to be migrating PHYSX Gym into Omniverse. And when I say into Omniverse, one thing to understand about Omniverse is that it is made up of a collection of extensions. Omniverse is a fully modular system. Individual extensions can be written either in Python or in C++ or some combination of both. And so what's happening with PHYSX Gym is we are bringing it in, we are updating it, and it will be another extension that's available within Omniverse, which means not just in Omniverse and Omniverse PHYSX Sim, but also in other Omniverse environments. So I'm particularly excited about some of the use cases in animation, which could have value in media and entertainment and other things as well. So we're going to get into what exactly this entails. So I will first focus a little bit on PHYSX Sim. So PHYSX Sim is available now. So if you're on a Linux machine, you can go and get the Omniverse beta, get the PHYSX Sim beta, and start playing with it right now. It includes a number of features which we believe are going to be very useful. So one is a much more complete URDF importer, which supports quite a bit of additional functionality. And of course, once you've brought your URDF models into Omniverse, that's when you get some of this higher quality rendering, because everything rendered in Omniverse is rendered with our full RTX ray traced renderer. You can get some amazing effects. In addition to URDF, we also support a step importer, which means that you can import models directly from CAD. So if you have a CAD model for something, you can import it directly into Omniverse as well. Similarly, we've taken our MJCF importer and we've brought that into Omniverse so that we can run the classical gym environments as well. Another thing that exists right now, you can play with in PHYSX Sim, is we have domain randomization for object placements. We have an extensive library of work around how to specify domain randomizations for objects in a scene. So of course, this could be really useful for a lot of different applications. Again, we make use of this ourselves very extensively in our drive sim efforts. So where we're using synthetic data to help train those models. We apply domain randomizations, and Omniverse has a complete suite of synthetic data ground truth output systems that you can hook into. So there's a separate presentation about that that I did for our GPU technology conference that you can check out. But without further ado, physics. Philip is on our physics team, and he knows a lot of the stuff much better than I do. This is Omniverse, and I have a different sample loaded, but I'll load up. I was going to start with the tendons. So this is a fixed tendon example. So these are the kinds of tendons that are actually used in the shadow hand that we use in PHYSX Gym. And Philip, I'm going to let you address how these tendons work and the difference between these tendons and spatial tendons.
Yeah, so fixed tendons are basically creating equality and inequality constraints on weighted sums of joint angles. And in this example, what you see is on the first joint, the green yellow one, it has a joint drive, so which commands it to 0 and 45 degrees. And then the second joint is linked to the first one through this fixed tendon, which just creates a constraint between the two joint positions, basically. So the second joint is passive in this sense. Yeah, in that it's not actively controlled, but yeah, forced to follow the first with the constraint, an equality constraint in this case. But you could also, yeah, with the inequality constraints, you could also have one-sided motion.
Excellent.
Yeah,
And
it's
then
not very spectacular, the fixed tendon demo.
and then I'll show also the spatial tendons.
Mm-hmm.
So can you explain what's going on here?
Yeah, so here, this is an articulation, so the same as you would use for Franca, for example. So you have a fixed base, which is the cube, and the capsule is connected to the cube with a spherical joint. And then the spheres that you see are attachments, and then a spatial tendon is basically creating equality and inequality constraints on the line of sight distances between these attachments. And here, this is actually a single spatial tendon that spans, that branches at a root that you don't see, which is at the center of the cube, and then branches to the four magenta attachments, and then to the attachments which are on the cube, and then the four attachments on the capsule. So the idea here is that, yeah, you could, I guess you could create series elastic actuators using this, because the constraint force are spring dampers, or you could, and one idea or one future thing that we want to do with these is also use them to simulate muscles, for example, or muscle forces on a skeleton.
So so this is a more complex example of a lot of things happening at once. So what you see here is a deformable, an FEM deformable hand that is attached to an articulated skeleton. So underneath that hand, we have an articulated skeleton. That skeleton is being actuated by joint drives from motion capture data. So we have motion capture data from a leap motion sensor that's giving us the palm pose and the joint angle targets, and then the FEM deformable mesh is running in PHYSX and is attached to the internal rigid skeleton, and it's actually holding that mug, that glass mug, entirely through friction. There's no direct, cheat attachments there. That's actually just the friction forces on the deformable body holding up the mug, and then we have position-based dynamics for the fluid, and that's then being rendered using marching cubes. So I'll show that one more time. Oh, and then the candle over here is being rendered with our flow simulation system, which is a separate simulation engine for certain kinds of gases and smoke and similar effects. So underneath, so this is the model with the skinning, and then this is the skeleton afterwards. The red fluid has a little bit of viscosity. We did this originally around Halloween last year, so it's a fun little example. And then, so speaking about deformables, we now in Omniverse we have these FEM-based deformables running within PHYSX with full GPU acceleration. The deformables in PHYSX have both a skin mesh, which is the visible mesh, There's a collision mesh, which determines which parts of the deformable actually collide, but the simulation mesh is actually larger than the collision mesh, and it's that way for simplification of the simulation. And collision forces are then added into the simulation side. Philip, did I get that right? Is there anything else to add
yeah,
there?
maybe just to answer Kirill's question from earlier for Yash. So, and the skin mesh obviously can be textured. So with this feature, you'll get what you what you were asking. That you can add textures or colorize the skin mesh however you want, and then
which is in fact exactly what you see here.
Yeah, this is not a texture, just a material, but a
Okay.
render material. But yeah, you could actually, it would be, if I had more time, I should have put a skin texture or something. Yeah, and fingernails next time. Yeah. Anyway, yeah. Sorry.
So this is an example of fluids. This is all running. It's all running in real time, and we have fluids interacting with both these physics bodies here. These rigid bodies interact with each other as well as with the fluid, and with the glass wall as well. Some pretty nice rendering happening here. All right, and then we were talking about cloth, so I'm going to load up our cloth scene. So this scene has this fixed piece of cloth. When I press play, it plays, and I'll just choose too close. That one seems to have fallen through. It's not a perfect simulation. So you can actually grab one of these cubes and move it around and push it with the other cubes. Philip, why don't you sort of talk about the mechanics of how we're simulating the cloth as a particle-based simulation?
Yeah. So each vertex of the cloth mesh is a particle, and then you have spring constraints on the distance between the particles, and then from a virtual thickness or thickness parameter that we set on the cloth and material properties, as the Young's modulus, you get the bending stiffness you calculate that from that. I think there's it's just a particle-based cloth simulation.
Inflatables.
Yeah, inflatables are the same as cloth, just with an internal pressure constraint as well.
I like the inflatables because I like how the solid objects interact with them. And then now one of the things, since we're running in Omniverse, what you're seeing here is these objects are all being brought in through USD. And what you're seeing here is the live properties of these objects in USD. And of course, because we've added the physics parameters, so some of the physics parameters are based on the new physics schema that has been agreed to between Apple, NVIDIA, and Pixar. But then we have a few other things. So things like inflatables are not necessarily in there, but I can go ahead and I can change the pressure on this. You can see sort of how that affects things. It gave it a little bit of a bounce. These look awesome. Similarly, I can change the masses of objects. So I think even these little cubes are sufficiently massive that, all right, let's try a different one, that they can squish the objects quite nicely. But then if I set that pressure higher, You can see it start to try and escape. Actually, I'm gonna take this guy. I'm gonna change its mass if I can, or I'll change its density. Oh. Now it's somehow gotten trapped inside. There we go.
Live demo.
Live demo.
So I think one thing that I'd like to point out while we're looking at the cool new physics features is that when we're moving Isaac Gym to Omniverse, you're also getting this full editor capability, right? So you'll be able to like set up an environment using the editor, using drag and drop features. We have a really cool physics placement mode that's physics aware, so you can actually position, add new assets, add new actors, position them in a physically realistic way without intersections. So it's an improvement over doing everything procedurally, right? Like the procedural generation that we have in Isaac Gym works for very simple scenes, but for anything more complex, having an editor is definitely nice, right? And you have a UI where you can inspect all the properties and actually play with the properties really easily without tweaking your Python code and then restarting it and stuff like that. So the editor is actually a pretty big deal, I think, for a lot of people.
Yeah, absolutely. And the last one I was going to show was rope. So this is a nice little scene where these ropes are just a series of it's a capsule articulations.
It's not an articulation. It's just rigid bodies. Yeah.
Sorry, rigid bodies. I apologize. I apologize. And we can pick them up and we can braid them, which is pretty cool. I tried tying them into knots. It's a little challenging with the way that
with the shift click drag.
The shift drag. So we'll have to work on that a little bit. But you can definitely.
But that's where the robotic hands come
them.
in, and you can like grasp them. Yeah.
But obviously a lot of possibilities here. And of course you could change the number of links to have higher definition as well. And what I love about this is that you can get the glass in the fluid, so you can see the refraction of the fluid in the glass, and here's what I like doing. This is all totally live. Hold on, I'm gonna redo that. It's all totally live. It all just works, and it works in real time. So many exciting possibilities here. The rendering is great. This is our
There's soft grippers on the fingertips too. I'm not sure if you mentioned that.
Yeah, this was the first iteration of the hand. Yeah.
Yeah.
And here we see a fluid where so this is without the marching cube surface extraction, but both fluids, the one we saw in the glass cube and this one, is particle based and position based dynamics, so PBD particle fluid, and then just rendered each particle as a small sphere.
That one is just way too cool not to play with. All right, so with the updated Omniverse based gym, all of those features are going to be available to people who are doing work in RL. So all those soft body physics features, we have other features coming for different types of simulation. I'm not gonna show those yet. Improved tendons, articulations. We have then also the ability to make use of all the additional sensors that we have in Omniverse. So you can have multiple cameras, you can have depth cameras, you can have segmentation cameras. We have LiDAR, ultrasonics. We're going to have more sophisticated force and contact systems, and we're going to be able to hook into other ML frameworks, and as Lucas said earlier, editor. One other thing that is aspirational right now, we did play around with this, is the idea of doing simultaneous tiled ray tracing. So rather than having each camera be its own thing, because we're ray tracing, we can now just direct the rays to originate from different cameras and do an entire tensor of simultaneous rendering. So this is just a very first shot at it. This is now about 18 months old, and we're hoping to make this available. This is probably not going to be in the first release we do of the integrated Omniverse Gym, but it's pretty exciting for anything that involves adding vision into an RL setup. All right, Lucas, do you want to talk to the new Tensor API?
Sure, yeah. Okay, so what you see on the screen here is that Franca Cube IK, which is done with Jacobian matrices, which we originally published with Isaac Gym. This is redone in OMNI Gym, and I wanted to use this opportunity to talk about some of the API changes that we're bringing, which are hopefully an improvement. So like OMNI Gym is an entire re-implementation from scratch of Isaac Gym, built into the Omniverse platform, right? So the benefits are that we're getting all the cool latest features from physics and rendering, sensor. We're able to share components with other projects like Isaac Sim and Drive Sim and Data Studio and all that synthetic data pipeline. So it's definitely a much more powerful ecosystem of applications and individual extensions that you can put together in a way that makes sense to you. The unfortunate thing is that you won't be able to directly take the same code that you had for Isaac Gym and just have it run in OMNI Gym. Most likely, there are some changes. The changes are for the better, and we're very aware of this being a pain point for people switching from Isaac Gym to OMNI Gym. I have to rewrite all my code. And so we're taking a lot of care to make sure that what we're creating is like a spiritual successor. It's not a complete reinventing of everything, right? So even though, the APIs are slightly different, the core concepts remain the same, right? So earlier today, I talked about, all the different tensors that we have in Isaac Gym, the actor root state tensor and rigid body state tensors and DOF state tensors and net contact forces and Jacobians and all of those tensors. They persist in Omniverse Gym. The way you actually get them is a little bit different, but, a lot of the code, a lot of the approaches, a lot of the concepts are similar, right? So there is a sense of continuity there, but we also took a lot of user feedback and even our own internal experimentation into account, and we decided to take this opportunity when we're moving to Omniverse, we're moving to this new platform to improve the API, right? And so looking at this code, I'm not going to go through it line by line, but I'll sort of look at the chunks. So the very first line there, there's a call to a function called create simulation view. So you create basically this object that lets you interact with a running simulation that has multiple environments configured in it. Everything is actually set up in USD, and USD has a hierarchical structure, much like XML, but it's like XML on steroids, right? Because it's very extensible. It's layered. It's very, very powerful, right? So all physics properties, all visual properties are defined in USD, and we can work with this very easily through this new Gym API. So one of the things that we wanted to do is make it easier to use something like PyTorch to interact with the running simulation. So in Isaac Gym, the original iteration, you had to go through this process of like wrapping and unwrapping tensors and refreshing tensors, and that was clunky, right? Like there was a reason why it was and it is like this, but we feel that we can do better, and so we find that the new API is a little bit easier. There's less boilerplate code that you need to write. It's more intuitive, and it's harder to make a mistake. It's harder to forget something like refreshing a tensor or something like this, right? It's you no longer need to wrap tensors into like PyTorch or something else. We built in support for different front end frameworks, right? So if you want to work with PyTorch, great. If you want to work with NumPy, great, but you don't get GPU acceleration with NumPy necessarily. You want to work with TensorFlow, great. So you will create like these simulation views or articulation views or rigid body views that natively give you PyTorch tensors and accept PyTorch tensors, and all of that like wrapping, unwrapping, all that data shenanigans is done under the hood, and you don't need to worry about this. And there's no big impact on performance because of this. It's just a nicer, neater, newer API. So another thing of note is that in Isaac Gym we use these global tensors, which means everything was in the same tensor. And if you wanted to get access to specific rigid bodies, let's say, you had to know the index, right? Where that object lives in each environment. And there was an API for doing it, but it was a little bit clunky, especially if you had complex scenes with lots of objects. There was a lot of boilerplate code that you had to write. So what we've done in Omni Gym is that you can actually create specialized data views, right? And customize the views. So let's say if you want to get a view of all the Francas in the scene, you can very easily specify, hey, like give me a view of all the articulated entities matching a specific path pattern, and the path is a USD path, so it's a path within this USD stage, and so you get an articulation view, and then you can work with that view and apply controls and get transforms, get velocities for all of the Francas in that specific view, right? So you don't need to worry about like that global indexing and being off by one and stuff like this. So it's a little bit easier. So we feel that's a useful sort of usability innovation there. What else? Applying controls, it's the same idea, right? It's like you don't need to, like if you create a tensor in PyTorch, you don't need to manually wrap it or unwrap it or like pass the scripters. All of that is done under the hood. So you basically, when you create your original simulation view, you just specify a string saying, "Oh, I want everything in Torch," right? And then what device, you specify the device that you want it on. Do you want it on GPU, on CPU, or whichever GPU device you want, you can specify that. And then all of the tensors that are used in those views are on that device. So it's a little bit easier to use, more pleasant to work with. So yeah, but all of the familiar things, if you've used Isaac Gym before, you will there won't be like a massive shock in terms of how do you work with physics simulations, because under the hood it's all the same concepts.
One last thing. So we are planning on doing another release before Omniverse Gym becomes public, or at least we hope before. We have a lot of work to do, so we'll see where things end up in the schedule. But we are going to do another release. We're gonna be adding in some of the new PHYSX simulation engine features, such as higher articulation link limits. We have a few more environments, such as the combination of Allegro hand and Kuka arm. That's not correct. Operational space control examples. We have mass matrices and faster Jacobian acceleration for IK on the GPU side, and we're hoping to provide some APIs to simplify terrain usage for locomotion tasks. And that is it for the futures presentation. So the fluid demo, that's a question to Philip. So the question is the fluid demo using PBD, NPM, or something else?
PBD.
Philip?
Yeah, position-based dynamics.
And then in terms of differences between the Omniverse PHYSX cloth and earlier Flex cloth. Can you comment on that?
I honestly don't know because I'm not familiar with Flex. Yeah. Maybe Victor would know what know more about the differences, but yeah, I'm not sure yet.
All right.
I'm not very familiar with PHYSX.
Okay.
Yeah.
I think like in general, the features, the soft body features that were in Flex originally, they were originally developed in Flex, are being ported to PHYSX. Whether they're ported in exactly the same way, I'm not sure, but yeah, that didn't really answer anything really.
In general, Flex
yes,
is the research engine that we use to to play with some of these features, and then PHYSX is where we implement the industrial strength version. And of course, lots of stuff is also implemented directly in PHYSX, but Flex was where some of this work originated. Suffice to say, if anything, it ought to be faster and better in PHYSX by the time it makes it in there. All right, so another question around performance. What's the performance of the PHYSX soft body features? Again, as I said, it should be faster. In general, because we never implemented the full end-to-end GPU reinforcement learning approach using Flex in Isaac Gym, once we're in that with Omniverse and PHYSX, you'll definitely get faster performance. You probably won't want to do something like sample the every vertex of your cloth mesh or something like that as part of your RL. Maybe you will. It'll all be running on the GPU. The state will all be there. So maybe we will expose that. It's not clear how much of these that will initially expose on the RL side, but we'll have the capability of exposing all of it if you want. Next question from Daniel Seda. Right now with soft Gym, it's hard to dynamically add items to the environment, and it will be rectified. And the answer is absolutely yes. So some of these features will be available in a very short period of time in beta in Omniverse. So I definitely recommend that everyone grab the Omniverse beta, start looking at it. You can grab the Isaac Sim, start looking at it. Isaac Sim has a dynamic control API that was inspired by the earlier version of Isaac Gym, pre end-to-end GPU. So you can play around with some of that, and yeah, stay tuned for beta access to some more of the physics. And there's some questions around demos available for tutorials. So in Omniverse, I'll share my screen again. All of these demos have source code. So some really basic things like just here's showing a really simple articulation. Here's the source code for doing it. Within the main thing that you're switching over to, going to Omniverse, is you're going to be using the USD APIs. That's you can start looking at this right now. Those APIs are all available through Pixar. You can look at them. There's a website with great documentation about those APIs. All of the standard physics properties are now part of the USD standard as well. So those are all in place. And this is just directly creating this scene by creating objects in the scene and setting properties on those objects.
Just to sort of build on that, yes, everything is constructed in USD. The scene is defined in USD, but as part of Isaac or Omni Gym, you do get a simpler API to construct the scene if you'd like. So you don't need to actually configure everything in USD. You don't need to learn an entirely new data representation API. we still will provide an easy API to construct a scene from multiple assets, just like before. But you can go, if you want to go deeper, you can actually edit all the individual USD properties, and then get deeper into that full data representation stuff.
My physics menu went away, so I don't know how to add mass to this object. Oh well. Yeah, ballpark estimate for lease. I don't have an answer for you there. We're working hard on it, and I'm hopeful that we'll have something soon. But there's lots of the features are going to be available to test through Omniverse already. All right, and that does it for me. You can download the open beta now, and you get the launcher, and you can play with a bunch of the apps that we have available right now.
I wanted to add that the developer links for getting Isaac Gym and Omniverse, and specifically Isaac Gym, there's also forums there where you can post questions or feature requests for the current Isaac Gym and Omni Gym going on forward. So that's another way to maintain dialogue with you guys once you get your feet wet with the environments. Yeah,
so on the Omniverse side, that forum is here. Again, I'll post this to the chat. We also have an Isaac Gym forum, and apologies for those of you that we haven't gotten answers to. We'll try. We've been busy with getting this presentation together and all the Omniverse work.
Maybe I could ask an extended question, which would be nice for everybody to hear. So I transitioned from being kind of working with the team internally a little bit to being an external collaborator. And I was wondering if there's like a little bit of a plan to build maybe a community around using things that you're describing, Isaac Gym, transitioning to Omniverse and so on. So how would people interact? I mean, maybe one could see read some messages on the forum, but maybe there's some other avenues of interaction for people who are, let's say, not interns at NVIDIA, who are external. How can they interact with each other so that they can help each other, so that you are not the ones always having to answer the questions?
Yeah, absolutely. So, I mean, the forums are definitely one way that can happen. I think in terms of other ways that the internal team can work with people, we do have, depending on the work that's happening, please let us know about anything that you're doing with Gym or with Isaac Sim and Omniverse, and we'll connect you with the right folks internally to help support that work. And we do have some internal Slack channels for some of those projects. But in terms of external community, I think it's a good question. Beyond the forums, is there a good place? And I don't have an answer for that. I'm not sure if Leela is on the call right now, but she may have. Yeah.
One idea could be setting up an external Slack channel that could retain some history. If that's easy for NVIDIA to do, that would be great, because I found the internal Slack channels to be immensely useful, right? And so just having this functionality, but for external users, it will relieve a lot of pressure, because people will be asking the same questions and they will know it's the space to go. So something like this would be great.
We already have an external Slack channel for support of external users. A lot of them were former interns or collaborators in some sense. So maybe, yeah, send you an invitation.
I think the question is going to be around sort of how broadly does that open up, because we have we have that for a limited number of people. How broadly we're going to open up, and I think that's something that's we'll have to give some thought to.
Yeah, that's a good question. Currently, it's more not open, more for former interns and former collaborators. And
I think there's a suggestion having an NVIDIA Omniverse Discord. Yeah, we'll definitely take the idea of opening up the Slack channel further, or Discord seriously, and yeah, hopefully we'll have some answers soon. I know that there are some users who are there's some kind of Discord that folks have been using for Omniverse. I don't know how widespread it is. There's another question about clarifying features of the future version of Omniverse Gym are not in the current open beta. So the current open beta, there's a handful of the physics features that I showed off that are not yet there. Those should be there later on this summer, possibly quite a bit sooner. Aside from that, essentially, you can think of Gym as plumbing on top of physics that allows us to have this more direct access to all the state on the GPU. So all the physics is just going to be what is in Omniverse. There are a few places where, as we work with both internal researchers as well as external partners, some of the work in PHYSX is going to be moving to support some of those features. So we have some stuff going on right now with improvements to spherical joints, for example, for some of the animation work we're doing. So that work is that work happens in the core PHYSX, and it's shared directly within Omniverse first. That's really one of the reasons that we created Omniverse in the first place. Is we wanted to have a place where you could have this integration of all these different features that we've been developing for some time all together in one place, and that's what Omniverse is all about. I want to thank everyone so much for all the hard work to be able to put this together. Huge effort from all the presenters, from Victor and Yash for organizing and getting things going with RSS. All the work underneath the hood from the physics team, tremendously valuable for all this. Staying up late for Philip out in Europe. Everyone who did a presentation, all the external collaborators, Rika and Jackie and Isabella. Thank you all so much for all the hard work, and we hope this has been useful, and we hope that if you have questions, you'll engage on the forum, and we'll look into other options in the future.